Hey, this is Jake from BIM Templates. In this video, I wanted to go over fill patterns in a little bit more of a nuanced manner. I see plenty of videos on YouTube discussing how to add fill patterns and how to kind of create some rudimentary fill patterns using, different tools. But in this one, I wanted to go into some of the more nuances of a fill pattern file and how to set those up and make them as efficient as possible. Because using some of these tools like PyRevit, it will make a pattern file, but if you're not careful and you don't know exactly what you're doing, it will create a pretty bloated, pretty line heavy pattern file. And so what I wanted to do is discuss some of the things, some of the principles and how files are set up and how to create them the most efficient way you possibly can. So to start off, pattern files are basically just a collection of data points about how a line is supposed to be rendered on screen. So in this example here, you can see that we have continuous line set up. There's no breaks, no nothing. All we do is just have a line that is repeated every inch or every 2 inches. And that is reflected over in these numbers over here. And so these numbers are what you see in a typical pattern file. And what the numbers are, they control the angle, they control the X and Y positioning from the origin. And then we have a number that controls the shifting. So the shifting is specifically the shifting of the line along the same vector. And so what that means is if we have a line length that is only 2 inches, and then we have a shifting of 1 or 2, that would mean that once this line is done, it'll be shifted over one. It'll be shifted over one. And then the same thing with this offset, but this offset controls the perpendicular offset from the original line vector. So in this position, we're controlling the shifting, but then in offsetting, we're controlling the offset perpendicularly. You can see that here. And then these last two numbers control the line dash and the line space, specifically the length of the line and the spacing between where the pattern repeats itself. And so in this one, we have them set to 0, which basically enables Revit to allow us to have a continuous line, and it doesn't require Revit to create another line as soon as this one's done. It just says, all right, this is forever one straight line. We don't have to ever calculate a break in this line. And so we have this cross pattern. It's set up the same way, but it's rotated. So this one's rotated 90 degrees. And one thing to note when you're setting up lines is the default position for lines is a horizontal position. And then when you add a angle to a line, it basically rotates it counterclockwise. And we'll see that in a different pattern later. But to know that when you're creating a pattern, the lines are being rotated counterclockwise from the origin point, not clockwise like some people might be familiar with. So that's something to be aware of when you're creating lines. So this one you can see, again, just a continuous line pattern, crosshatched. We can set this up to be a little bit different where it's only a 1 inch and 1 inch and the other orientation can be a 2 inch. But that's like the bare basics of how lines are rendered. We can get into more complex patterns over here. If we were to add something, we were to add like the shift and an offset, not just an offset, and we can play with the length of the line and the spacing of the line. And in this example, we can see with our horizontal lines, because this is 0 and a vertical line is 90, you can see with our horizontal lines, we have a position, it starts at 0, and for the Y, it starts at 0. But we have a shifting. Shifting, again, is along the same vector for the line length. So since there's a horizontal line, we want to shift this line over. So the next time the line repeats, it's going to be shifted over 0.5 inches, so half an inch. And then we want to have an offset, if otherwise we just have an extra long line here, which wouldn't really render correctly. So what we want to do is have a shifting. Or we want to have an offset. So to offset it, we offset it 1 inch. So basically we're telling Revit is we're saying a line is here and it's this length, and then we're also repeating the pattern in this orientation. So it's shifted over half an inch, and then it shifted it up 1 inch, and it just repeats this until forever. And we're also adding a line length, and we're also adding a spacing. So we can see that our dashes are a 2-inch length, and then we have a spacing that is a 3-inch length. So this means that we're repeating the pattern in this direction, but we're also shifting the pattern over. If we're going to shift the pattern over to repeat in a horizontal direction, we're shifting the pattern over 3 inches. So basically, the offset is a vertical or a perpendicular offset, and then the spacing uh, is a parallel offset. And this works in the same way as we do with the 90 degrees, or the vertical lines. It works in very much the same way. We have a 1-inch shifting, we have a 2-inch offset, we have a 3-inch dash, and then we have a 4-inch spacing. And so again, we have the rotation that's set at 90 degrees and it's going counterclockwise. And this is how we're achieving all of the different patterns and different lengths here. One thing to note when we are setting up line spacing is the lines have to be set to a negative number. I don't really know why, but all of the line spacing has to be a negative number. And I think that has probably something to do with like the second placing of the line. I'm not really quite sure. If you know, please elaborate. If we go a little bit further and add something that's a little bit like a wonky angle, and we do mess around with the X and Y orientation, you can see that we can get some pretty unique patterns setting up here. One thing to note is, to reminder, like when we're doing a offset, the offset is perpendicular to the line itself, rather than just a perpendicular to, say, the horizontal line itself. So that's why sometimes you can get this pattern where this line is actually going down at an angle like this instead of it just being rendered right here. And this can cause some problems when you're setting up some tile patterns and they have some certain angles you need to do. It's just stuff that you need to be accounting for when you're setting this stuff up. So you can see we got a 1-inch shift here, and the 1-inch shift is right here. We got the offset. The offset is also right here. We have the line dashing, the line dash is there, and then the spacing. We're doing the same thing here. But you can see if we extrapolate this pattern, stretch it out, we just have the pattern just being shifted towards infinity. And this enables us to create some pretty unique kind of patterns and working with setting up, our own custom pattern set. So in this example, what we've done is we've created a brick pattern family, but we also have a couple of offset lines in there. And that is to create the illusion of like a proud brick. This could have been created with one line. We decided to create two just to add it and make it look a little bit more, punch it up when we're looking at it in elevation. And so you can see we've added it's rounded right here, but it's a 1/8 of an inch offset, and this other line is a 1/4 inch of an offset. And these are offset specifically from the origin itself, and that's where the X and Y offsets come into play when you are setting up patterns like this, because you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines in one family, but each one of these lines can adhere to a different pattern, angle, a different shifting. They don't really all have to be at the same angle when they're doing these origins. And so in this example, we specifically had one pattern and two patterns. So the brick pattern is following its own angle, but it has its own shifting, its own offset. But then our proud brick has its own offset. It's its own offset to way over here. So it's not just repeating to the same distance that this brick pattern is. And so you can get some pretty complex line work going on in here and different spacing, just so you can create this illusion that you have this pattern set. And so this number set is basically broken up into the proud bricks, and then we have our typical brick pattern. And so if you look at this red area is basically how the offset kind of works here. We have the brick pattern is kind of going at this angle, and so the brick pattern line work is just being repeated in this direction, and then it's being shifted over and repeating the direction again. But then we have these interior proud lines, and those are being shifted around this red box area. So if we were to copy this over and to either shift this over here or shift this over here, you can see we would have the same pattern repeated again and again and again. And this is how we get very even patterning. Otherwise, we would be creating, if we didn't do this sort of orientation, we would then have like a bigger box that would be something along the lines of this, something like this, where we need to have a pattern here and a pattern here. And we don't want to do that because that then creates extra line works. It creates extra rows. Revit has to calculate and render all that out. And so it just makes things a lot simpler. To illustrate this, I have this little program that I use called pattycake.io. It's a website. You can get a license for this. It's extremely helpful. It makes it a lot easier for you to be able to visualize and in real time get real feedback on how the pattern is being calculated and rendering out. It's a lot easier than doing just a text file and then copy and saving it, loading it into Revit, and seeing if it works or not. So it's a very immediate feedback. One of the main features that I like about this is it actually does, for each of these rows, it'll assign a color into the rendering view. So I can actually see in real time which lines I'm actually adjusting. So I'm not having to guess and remember which lines are what. So as you can see in this one, we have our purple line, which is our continuous horizontal line, and then this is our vertical line that is being arrayed across in this direction. And then we also have our offset proud bricks, and those are also being arrayed across their own orientation here. And so this is like a very, very good tool to be able to visualize everything and when you're setting up these patterns. And so that's one of the things that helps is when you're actually setting it up, because it'll automatically show you, oh, it repeats this way, it repeats this way, or it repeats this way. So I would highly recommend if you do Patty Cake, use them. It's a very powerful tool. They have templates. They have some libraries for preset families of patterns that people have already made. And you can export to CAD, millimeters, drafting, whatever. But I use them specifically to help me visually create the pattern when I don't really want to do it by hand with PyRevit, or when I want to make sure the family is a little bit more efficient. One of the other methods I use when I am creating patterns and that people talk about is to use PyRevit. And PyRevit is a very powerful tool that makes it really easy to make patterns. So simply all you need to do is just highlight and then go over to PyRevit and then click Make Pattern. And then we go into circles. We'll just say it's circles. We can specify whether it's a detail or a model pattern, and we can also create a filled region when we're also creating it. We can change scales and we can rotate and everything and flip. We can do all this fancy stuff here. So I'm just going to create a filled region here, and I'm going to create the pattern. I need to specify the bottom left and the top right. All right, cool. So now we have that pattern. So if we were to copy and change this to our circles, you can see that we have a pattern that is created here automatically. Now, one thing to note, I created this using the circle line tool. When you're creating patterns, you cannot have a perfectly rounded line. So all lines are basically curved or filleted surfaces. So you can see in here when we zoom in that the resolution that PyRevit exported these the circled, or it basically interpolated the circle into filleted lines, and it effectively filleted it around this resolution. So that's one thing to note is if you have a very small pattern and you're using curved lines, that they will be filleted, and so that's something that you need to be aware of when you're setting up these patterns. But now that we've created this pattern, one other tool that we can use is we can actually export using PyRevit. So we can actually go into here and we can find the circle pattern that we already created. Whoop. and we can export the file. And let's see, so it didn't export the file. So one tool that I like to use is HatchKit 4. HatchKit 4 is an additional plugin that you can get. You can purchase through the Autodesk library. And what it is this is one of the original tools that helps to create fill pattern files. So one of the things that I like to use it for is I like to use it to help me with scaling of my fill patterns and exporting fill patterns, especially in older versions, because in Revit 2026, we finally have the ability to export a fill pattern, but there are some things that to be considered when it comes to that. So I like HatchKit because I can export it directly from here in older versions. But one of the other benefits of HatchKit 4 is that we can actually go and see, all of the different information about it, where it's used, some of the styles, what the orientation type is, or the type is, and we can go in here and edit the pattern itself. And so one thing that I really like is I can actually scale things. I can change things from inch to millimeter. I can rotate it. I can move things. I can even combine two different patterns together into one file, which is immensely helpful if I have two different patterns, and it just makes it easier to just create a brick pattern here and then duplicate and create this little pattern here, which is what I did here. And then I combine them. And I can easily scale it to half the scale here. It'll replace it. And you can see that we easily rescaled everything. And that's one of the powerful tools that I like to use is PyRevit. So is a HatchKit 4. One thing to note on the topic of scaling. So Revit has the ability when you import filled patterns is they can actually scale patterns itself. So if we go into here, you can see we can change the import scale. So it'll just take whatever the original pattern file is and it'll just multiply that. One thing to note about that is it's imperfect. I don't really understand the reason why, but it doesn't always work, especially at smaller scale lines. It doesn't really render out properly. So you can see here is this our original pattern right here. It's just set at a 1-to-1 scale. This one we half the scale, so it's half the scale. And for some reason, the line work all of it doesn't really scale. You can see it'll scale the X and Y direction, but in terms of like the length, it won't exactly apply all the changes universally. And you can see the same thing here when we've upscaled it, there's still like some line work that doesn't actually render out the same way. And so that's why HatchKit tool is very helpful, because HatchKit tool actually will rescale everything properly. And we can either override a pattern, create a brand new pattern at a different scale, instead of where Revit, it's just copying the existing pattern file and then it's just upscaling it. So we're not creating a brand new pattern, we're just upscaling an existing pattern. So I like using HatchKit specifically for that. One of the abilities that we have in 2026 is we can export patterns. And so it's really helpful when we're exporting patterns, because we can export patterns that are already taken care of. So fill patterns, and say we have a fill pattern created in 2024 or 2026, but we have a file that is set up in 2023 and we don't want to update the file. So we can easily just go into here, export the pattern file, and just set it to wherever, new pattern file, and it'll export it. And the great thing about this is that we can then open it up in a text file and we can take a look at it, and then we can re-import it into an earlier version. It's kind of one of the few ways that we can actually make Revit a little backwards compatible, but to a very limited degree. Something to be aware of when you are reviewing pattern files that are exported from Revit 2026 is it's not a perfect export, and not everything comes in that was originally imported into the file. So in here we have an example. This is our original pattern file. So pattern files are kind of structured where you need to specify the unit type, you need to specify the title, and you need to specify whether it's a model or drafting pattern type. And then below you have all of your lines. We have some more information that is added to this file. If you add the semicolon and then you just type in whatever, you can just, these are effectively just comments using the semicolon, and you can add this into the file and you can save this to your personal server. Um, but when we imported it into the file, everything looks fine. But if we export it, none of the commented information made it out of Revit. What's even weirder is the actual like units didn't even make it out of it. So I'm assuming it's when you're importing it back in, which it works, it's just going to assume whatever is the system unit that it is currently in if it doesn't have it specified. Um, but yeah, so none of the comment information shows up in the exported file, and along with, it seems like the angle family, the angle portion of the line actually renders out to a higher precision, as well as rounds it slightly for whatever reason. Because you can see in this file, we didn't have that level of precision, but for some reason it's exporting it like this. This is enough to be a problem when you are actually trying to dimension onto a model pattern file. So if you have another family that is another line that is a perfectly vertical and you try and snap a dimension to each of those, it's not going to snap because this is not a perfectly perpendicular line to that other line that you just placed. So that's just something else to be aware of. One thing to be aware of when you are exporting patterns that are created using PyRevit. PyRevit will be very, very precise with these lines that are made. So in this example, we use PyRevit to help generate this pattern file. There is a lot of lines inside of this file, and they repeat because this is a terrazzo, so it's supposed to kind of have that, and it's kind of used at a smaller scale. Um, and but it's going to have a lot of different lines, and it's going to have a high level of precision that was used to create those lines. So it's definitely something to be aware of when you're creating these files because it does make it a little unwieldy and hard to read. But it's definitely something that you should be aware of when you're using PyRevit. It does this with most families that aren't to an exact rounded whole number. And even to a whole number, it sometimes will have a little bit of wiggle room on that. But you also want to be aware of the when you're scaling patterns too, using either PyRevit or using HashKit, is that Revit only renders line work to 1/32 of an inch. So as you can see, let's go to thin line here. So if we draw a line here, if I would try and draw something that is under 1/32 of an inch, it will not render. So Revit won't even allow me to place it. So if I place it, see the element is too small. So what we want to do is we want to place something that is over 1/32 of an inch. But if we try to reduce that line, it'll just error out. Revit allows you to be able to move uh, Revit allows you to move lines under 1/250 up to 1/256 of an inch. So positioning wise, it's fine. It's just the length of the line itself cannot be under 1/32 of an inch. So that's something to be aware of when you are creating patterns like this and scaling them down. Because if you scale them down and you have some of these smaller line work in here, if it scales down and it's under there, the whole pattern won't render out at all. So the whole thing will Revit will error out and break, or it won't even import the pattern file itself. That's something that you have to be aware of when you're creating files like this and scaling them. I hope you can create your own custom patterns, and this was very informative.